Chapter 6 audio lecture, and for this part of Chapter 6 we're going to look at the formation of the bony skeleton, okay? And the proper term for formation of the bony skeleton is going to be ossification, and we want to remember that when we're kind of creating these bones, we're going to start off with these little models, right? And we're going to kind of take these cartilage models or these fibrous models, and we're going to eventually sort of turn those into bone, okay? So by week 8, the embryonic skeleton is constructed entirely from fibrous membranes and hyaline cartilage. Bone tissue begins to develop at about this time, and then again, the bone will eventually replace most of the existing fibers and cartilage structures, and your body's going to do this in 2 ways, okay? And we come up to our first little definitions from part 2 that are really, really important, and we get this endochondral ossification, which means that we're making bone by replacing hyaline cartilage. Okay, so this one we used a hyaline cartilage model. Intramembranous ossification is that bone develops from our fibrous membranes. Okay, and we're going to use these flexible structures initially because again, this is what allows our bones to grow. So endochondral ossification, this is the most important one because it is the most common, okay, and this is the one that I want you to kind of focus on throughout these chapters, but it accounts for all of the bones below the base of the skull except for the clavicle or the collarbone. Is going to begin in the 2nd month of development. And again, is using a hyaline cartilage bone model. And then again, we're going to take this model, we're going to gradually replace that cartilage with bone. And it's going to start at a primary ossification center. And we're going to look at the steps of endochondral ossification. But again, we want to try to keep it really, really simple. So we just want to know how the first one kind of leads to the next one and just have a basic understanding of what's going on in each step. Okay, so what is a primary ossification center? Bone formation begins in the center of the hyaline cartilage shaft, and we'll see the picture here in a second, but important to remember that this formation of bone is beginning at the primary ossification center, and then that is going to be located in the center of that hyaline cartilage shaft. So blood vessels are going to infiltrate the covering of the hyaline cartilage model. Everything always starts with blood vessel or blood being available and nutrients being available. We're creating a vascularized periosteum. As a result, the underlying cells begin to specialize into osteoblasts, and we know that those are the ones that lay down the bone for us, and then this ossification process can begin. Okay, so a lot of things are going to start with, do I have the nutrients and do I have the blood supply to do all the things that I need to do? So here is our picture of our model, and then again, we just get this little image of where's that primary ossification center, and it's in the center of that shaft, okay? And this is going to be step 1, but we'll look at all the steps here in a second. So here is a little summary of all the steps of creating these bones through endochondral ossification. And again, this is a good little summary of what's going on in each step and again, how each one kind of leads to the next one. And I can see from the pictures where I have, this cartilage model, and then gradually I'm just replacing all that cartilage with bone, okay? But it starts in the center, and eventually I'm going to do the ends, and then I can still kind of lengthen my bone for a certain period of time through these little epiphyseal plates where I kind of maintain a little bit of cartilage at that plate so that I can gradually just add more and more bone. Okay, but we're going to look at each of the steps a little bit more in depth here as we go through the next couple slides. So the steps of endochondral ossification. Number 1, a bone collar forms around the diaphysis of the hyaline cartilage model. That's what we just talked about. Okay, so here is our hyaline cartilage model. We have our primary ossification center, and then we're going to sort of lay down bone on the sides here of the shaft and create this bone collar. So osteoblasts secrete osteoid against the hyaline cartilage diaphysis. We get, again, what is osteoid? If you don't remember, it's going to be unmineralized bone. Okay, so unmineralized components, creating a collar of bone or a periosteal bone collar. So that's step number 1. You're creating this bone collar. Okay, step number 2, the cartilage in the center of the diaphysis is going to calcify, and we're going to start to develop cavities. Okay, so we're going to start to, this cartilage in the middle is going to start to calcify. And again, the main important part about that is it's going to be the development of these little cavities. Okay, so how does that happen? The chondrocytes within the shaft are going to enlarge. They're going to signal the cartilage matrix to calcify, and that just means that we're going to start to deposit calcium. Why is that important? Is that the calcifying of this matrix is going to create this, make it sort of impermeable to nutrients, okay? And we know that when we lose our ability to get our nutrients, those cells are going to die. So it's going to cause the chondrocytes to die, and it's going to cause that matrix to deteriorate, and that's what's going to create these little cavities in the bone forming. So number 3 is the periosteal bud invades the internal cavities and the spongy bone forms. And again, this is just the delivery of, again, those nutrients and those cells that we need to sort of perform all these functions. So here is our model. We did our bone color. We calcified the center part, created our cavities, and now we have this sort of blood vessel that kind of comes in and supplies all these additional sort of nutrients and cells. So in the third month, the forming cavities are invaded by the periosteal bud. It's going to contain a nutrient artery, a vein, a nerve. It's going to have all our red marrow elements. It's going to have all our osteogenic cells, the osteoclasts. The osteoclasts are going to erode the calcified cartilage matrix. Okay, and then the osteogenic cells are going to turn into osteoblasts. And these, again, are important because they're going to secrete the osteoid around the remaining hyaline cartilage fragments. And again, we're just creating the earliest form of our spongy bone. Okay, but it's this arrival of this periosteal bud that kind of makes all of this possible. So number 4, the diaphysis elongates and the medullary cavity forms. We're also going to have the arrival of the secondary ossification centers, and these are going to appear in the epiphysis. So the first one was in the diaphysis. The second ones are going to be in the epiphysis. So here is our bone. We're turning the middle part. The shaft is almost all bone now. And then we have our secondary ossification centers that are going to start at the ends or the epiphysis, and we're going to start to turn the ends into bone. Okay, so as the primary ossification center enlarges, osteoclasts break down the newly formed spongy bone, and again, this opens up that medullary cavity in the center of the diaphysis from week 9 until birth. Okay, so week 9 until you're born, the hyaline cartilage model continues to elongate, and again, we know we just get bigger and bigger and bigger until we're born. Ossification chases cartilage formation along the length of the shaft. So again, we're going to kind of lay down cartilage, and we're going to turn it into bone. Lay down cartilage, turn it into bone. Shortly after birth, a secondary ossification center appears in one or both epiphyses, and then again we can start sort of adding more and more bony tissue. Okay, so here is our little picture of all our ossification sites. We can still see that the ends are still predominantly cartilage here, but we're going to turn those into bone. In number 5, so number 5 is the epiphysis ossify. So the ends are going to ossify. Okay, so again, I'm turning the ends into more bone. I'm still going to have cartilage, right, on the ends, and I'm still going to have cartilage at that epiphyseal plate where I can continue to sort of lengthen the bone. Okay, so once completed, hyaline cartilage remains in 2 spots. It's on the epiphyseal surface. That's because this is where our joints are forming, so this is our articular cartilage, and then we're going to keep that cartilage on the epiphyseal plates, which is the junction of the diaphysis and the epiphysis, but again, this is where those bones are going to kind of continue to lengthen from. Okay, and then here is again just a nice little summary of all the things that we just sort of talked about. And again, these are the things that I really want you to concentrate on, are these 5 steps and just knowing what happens, what are the important things that happen in each of the 5 steps, and how does the first one sort of lead to the next one. Okay, so postnatal, so this is after you're born bone growth facts. So during infancy and youth, the long bones are going to continue to lengthen, and again, they're growing at the epiphyseal plate. Bones are also going to grow in thickness, so not only do they get longer, they get a little thicker, and this is going to be the appositional growth, or this addition of new layers. Most bones are going to stop growing during adolescence, and again, we have particular zones where the bones are going to grow, because, I mean, you know, when you look at that picture back here, you know, once we sort of create this whole little bone in the shaft and bone on the ends, this is the only part that this bone is going to continue to kind of lengthen from. Okay, so that's what they mean. It's going to grow in particular zones. So here is a picture of your long bone, and again, in this part, we're just talking about the lengthening of a bone. So we're lengthening our bone from these epiphyseal plates, but I have sort of one side that's more active than the other. So there's a resting zone, okay? So cartilage is relatively inactive on the side of the epiphyseal plate facing the epiphysis. So if this is my epiphyseal plate, this top part here, okay, is facing the epiphysis, and we're saying that this is my resting zone, okay, and then this is the bottom part here, and this is my fast efficient growth zone. So it occurs at the epiphyseal plate cartilage next to the diaphysis. So if I look at my plate again, and I have this bottom part here, it's facing the diaphysis, so this is where everything is going to kind of grow from. And then we'll zoom in and we'll look what's happening on each little layer here, okay? So this is a zoomed in picture of my plate. Okay, and again, this is the epiphysis because I can see my articular cartilage here, and this is going to be my diaphysis. I can see the cavities, right? But I have my resting zone, which is the top line here. Just underneath that, I have a proliferation zone, okay, where I'm continuing to sort of add cartilage, right? So my cartilage cells are undergoing mitosis, or they're dividing. So I'm adding cartilage here, okay? And then at the bottom part, I'm turning that cartilage into bone. Okay, so this is my little ossification zone sort of down here at the bottom. So I'm continually adding cartilage, turning the bottom part into bone, and then what I'm doing is I'm just pushing this epiphysis farther and farther away from that center part until I get my bone to whichever length I sort of want it to be. Okay, so a really cool picture, and just a really cool picture if you looked at it under the microscope to kind of see. And this is, again, we looked at the hyaline cartilage, and again, this looks exactly like we did when we looked at the tissues and we saw those cartilage under the sleds. Okay, so during growth, the epiphyseal plate maintains a constant thickness. Okay, so the plate's going to stay the same because I'm always kind of adding cartilage, turning it into bone. So the rate of cartilage growth on the epiphysis facing side is balanced by bone growth on the diaphysis facing side. So just what we talked about. As adolescence ends, the chondroblasts of the epiphyseal plate are going to divide less often. So I'm going to stop adding so much cartilage, but I'm going to keep kind of adding bone from the bottom. The plate's going to become thinner and thinner until it is entirely replaced by bone. And this is going to signal the end of that, the lengthening of your bones. Okay, so longitudinal growth ends when the diaphysis and the epiphysis fuse, and then again, instead of an epiphyseal plate, I end up with just this epiphyseal line, okay, or the remnants of that plate. This is a picture of my little guy's wrist again from when he broke it, but I can see right here that he has this little plate here, right? So this is that epiphyseal plate, and you can tell that it's not sealed up, so you know that these bones are still growing. Okay, now this is where he broke his bone, and again, this is where it becomes really, really important, is that if he would have fractured it and he would have disrupted that epiphyseal plate, this bone or his, radius would no longer grow properly. Okay, so that would be a big, big deal. So any sort of fractures by the ends of the bones, especially when kids are still growing, if you disrupt that epiphyseal plate, it becomes a bigger issue and something that you have to monitor for a long, long period of time to make sure that the bones are growing properly. Here's another picture of my femur, my tibia, and I can see those epiphyseal plates, okay? And then here's one where it's more closed up, where it's more like that epiphyseal line versus that epiphyseal plate, okay? So someone that's either done growing or someone that's almost done growing. Okay, so now we want to talk about the growth in width or the appositional growth. So growing bones are also going to widen as they lengthen, but remember we're going to kind of keep that cavity in the center. So osteoblasts beneath the periosteum are going to secrete bone matrix, so on the outer surface or the external bone surface. Osteoclasts on the inside or on the endosteal surface are going to remove bone. Okay, so we're constantly, again, adding bone, removing bone, and this is an attempt to sort of make the bone wider, but keep it from getting too thick and keep it from getting too heavy. So we're always adding bone on the outside and breaking it down on the inside, and we're going to see a good picture here that kind of explains that pretty good too. Okay, so here is our bone here again. So again, we're always adding bone on the outside, but we're kind of continually hollowing out the center here too. Okay, so it creates this bone where it's kind of, the thickness stays relatively the same, but we get this increase in the size of the cavity. So the overall width of the bone or the wideness of the bone grows, but the thickness of the walls kind of stays very similar. And then again, we just sort of increase that size of that cavity in the center. So hormone regulation of bone growth until adulthood. So how do we control all of this? So bone growth is controlled by our hormones. When you're younger, so infancy and childhood, it's going to be growth hormone. As we get older and we enter puberty, it's going to be more our sex hormones. So testosterone, estrogen are going to get released in increasing amounts, and this is going to cause our growth spurts, okay? But it's also going to signal that epiphysis or the epiphyseal plate to kind of close and sort of signal the end of our growth too. Bone remodeling, okay? Your bones are going to change continuously, right? We're always kind of fixing them and remodeling them. So 5 to 7% of your bone is recycled every week. That's an astronomical number to kind of think about. Spongy bone is replaced every 3 to 4 years. Compact bone is replaced every 10 years. So it's not one of those things where you just kind of form your bones and then they stay like that forever. We're constantly remodeling and sort of fixing things and making them stronger. So if not replaced for long periods of time, and this is why this is important, those calcium salts are going to crystallize and your bones are going to become more brittle. Okay, so deposition and resorption occur at the surfaces of the periosteum and the endosteum, again, which we already talked about, and together these are going to constitute bone remodeling. So bone remodeling includes that deposition of new bone and that resorption of that older bone. But again, a good multiple choice question of what's included in this remodeling, and most people sort of forget about the resorption part and we just think about the deposition part. So total bone mass usually remains constant, but it is not uniform. Your bones are going to be thicker where they need to be. So wherever they absorb stress, your body's going to make them thicker. Okay, so controlling remodeling. Remodeling is regulated by genetic factors, and again, we're going to use two control loops, okay? So we talked about negative feedback loops a lot. For your bones, we're using a negative feedback loop, but we're monitoring the calcium levels in our blood. And then we also talked about where we're going to remodel our bones based on the forces that they absorbed, or they're going to have this ability to respond to these mechanical and gravitational forces that are put on the skeleton. So let's look at the negative feedback loop here first. So for hormonal control, it's going to involve the parathyroid gland, okay, and the parathyroid hormone. And your body's going to, again, use these calcium levels in our blood, okay? So it's using a hormone loop that maintains a narrow blood calcium level of 9 to 11 milligrams per deciliter of blood, okay? So a very, very small sort of range that we're trying to sort of maintain. Here's our picture like we saw in the first chapters where we have our little teeter-totter, okay? And when it's level, we're in homeostasis, or we're in balance. The stimulus in this case is this decrease or these falling levels of calcium in our blood. So again, your body's monitoring the calcium levels in the blood. If it feels that they're getting too low, okay, it's going to try to change that and bring them back to normal. So what happens is that it's going to stimulate that parathyroid gland to release parathyroid hormone, okay? And then you want to think about, okay, what does that do? Parathyroid hormone is going to stimulate my osteoclasts. We know those are the cells that are going to sort of break down bone for me. So my osteoclasts are going to degrade the bone matrix, and they're going to release calcium into the blood, and then that's going to bring my level back to sort of where I want it to sort of be, okay? And then I would stop stimulating the parathyroid hormone, stop releasing parathyroid hormone, and then I would be, sort of back to normal. But again, you're constantly sort of monitoring these blood calcium levels to make sure that they stay where we need them to be to function properly. All right, we also said we can respond to mechanical stress. So what do we mean by that? Is that your bones are going to respond to mechanical stress and to the force of gravity. This can be just gravity bearing down on your body, or the weight that you're putting on your body, or the muscles and how forceful they are at sort of pulling on the bones. So this keeps our bones strong where the stressors are acting. And what we really want to know is just that we have this Wolff's Law, okay? And what Wolff's Law states is that your bone growth or remodeling, or that we can grow our bones or we can remodel them in response to the demands placed on them. But mostly you're just saying that, okay, if certain parts of my bones are absorbing a lot of stress, my body is going to make sure that they're really, really strong. And if there's certain parts of the bones that do not absorb a lot of stress, it's going to make them a little bit weaker or not put so much bone down on there. So here is our little picture here. And again, this is my femur. You can see the head of the femur, but this is going to bear a lot of weight for me, right? So I can see where my pelvis is going to fit right in here. My whole weight of my upper body is going to come, and we're going to bear all this weight on our lower legs. And this is the perfect example of why all the bones in my legs are going to be way bigger and way thicker than my upper extremity, because again, they're bearing more weight, they're absorbing more stress from gravity. I'm producing a lot more forces kind of in those areas, so I need them to be that much stronger. Okay, so the best way to think about this is that your hormonal controls, and again, this is for good multiple choice questions, my hormonal controls are going to determine whether and when I break down my bone to sort of restore those levels of calcium, okay? And again, they're going to monitor those changing blood calcium levels, and when they get too low, they're going to start to break down the bone, and I'm going to try to restore those levels. The mechanical stress is going to determine where, okay? So the really cool thing that your body does is it's not going to break down the bones where it feels like they need to be strong. It's going to kind of take that calcium from parts that it considers not as important first. Okay, so important when bone must be broken down to increase calcium levels. My parathyroid hormone is released and targets the osteoclasts in the least stressed areas. So the least stressed areas in your body are the ones that we're going to break down first to kind of get that calcium kind of back into the blood. But if we continue to run out, eventually your body will have to break down the parts that are more important and sort of more, that absorb a lot more stress, and this can lead to kind of injuries kind of down the line, okay? So it's just based on, okay, I'm going to monitor my blood calcium levels and determine if I need to break down my bones, and then based on the mechanical stress placed on different part of the bodies, I'm going to break down the weakest spots first so that I don't disrupt those areas that need to be super, super strong. So that's the end of part 2 of chapter 6, okay? Sorry, not chapter 8. This is chapter 6, and then next time we're going to come back and look at the last part of chapter 6, which is just going to be some of the bone fractures, and then we'll try to just kind of tie the whole chapter together.